Hi, my name is Ragat Al-Saddi.
Hi, my name is Dilshan Mawasingh.
Hi, my name is Courtney Carter.
And welcome
to our
Capstone Project.
For our Capstone project, we wanted to do something very special and unique to separate our work from everyone else and make it stand out the most.
We wanted to create something which would grant us a golden opportunity to utilize all of our skills and learn nuances well along the journey. We had this vision where we wanted to unleash our full potential to the world to see in awe and go far beyond our capabilities, and we wanted to make sure we met that vision.
That's when we decided to build a smart house. A smart house allowed us to utilize all our skills and more and really release our full potential.
Smarthouse is a mini house where we placed electronics components like Christmas lights, a servo motor, and a fan. Those components are controlled wirelessly from our smartphone using an application called Blynk app.
Here is a list of all the components we used for the project.
Node MCU ESP8266. This is the MCU chip we use to control the operations of the project and to utilize the wireless features from it.
LM35 Analog Temperature Sensor is used to detect the temperature from the environment, then send the data to the MCU, which is then used to control the speed of the fan.
2N2222 transistors. These are used to act as a switch to control the servo motor and the Christmas lights.
100 ohm resistors. These are used as bias resistors to limit the current flowing to the servo motor and the Christmas lights, in order to not overheat them and overheat the whole circuit as a result.
40 LED Christmas lights. This is simply used to decorate the house and to add to the visual appeal of the house, and it will be switched on and off.
12-volt fan. This fan is what the LM35 temperature sensor is controlling based on the temperature of its environment.
800 mAh lithium battery. The PCB of the project is powered up with this battery.
Finally, we use one 4-cell lithium polymer balance charger. This is used to charge the battery and ensure that the battery is at full capacity.
We will now discuss the Arduino code we used to program the Node MCU. This is the Arduino code which we used to program the Node MCU. Here in the beginning, we have the libraries. The ESP8266 Wi-Fi library is used for the Node MCU. The Blynk Simple ESP8266 library is used for the Blynk phone app, and the servo library is used for the servo motor. This section of the code is how we establish the connection between the Node MCU and the Blynk app. The authentication code is used to specifically create a connection between our Node MCU and the Blynk cloud, only which allows the connection to be more private. These two lines are the access point details of the network we use. The output of the temperature sensor is an analog pin, which is A0, and this specific pin is used since it has an ADC in it, which will convert the data from analog to digital. In order to be able to determine the value of the temperature, we have to convert it to analog, which is why we declared in the code a V reference equals to 3300 mV. The ADC in the Node MCU has 1024 levels, as the temperature is read in analog data only. which is why we divide the reference voltage with 1024 to gain the resolution of the ADC. Over here we have declared the minimum and maximum temperature values, which the fan will be operating on based on what the LM35 temperature sensor reads. Here, for example, we set the minimum temperature at 25 degrees and the maximum temperature at 35 degrees. If the temperature reading from the fan is below 25 degrees, the fan will not operate. If the temperature is between 25 and 35 degrees, the speed of the fan will adjust based on those readings and go faster as the temperature goes higher and vice versa. We stated this D5 pin value because that's the pin we use on the MCU to connect the fan. So this function will be able to send the analog data to it. mapf is a function used to find the speed of the fan. This is used to read the analog data collected as a digital value, and the pin A0 is used since that's the pin used in the MCU to connect the LM35 temperature sensor. This equation is used to convert the voltage into an analog value. According to the datasheet of the temperature sensor, each 1 degree Celsius it sends gives off 10 mV. So by using that equation, it will convert the voltage value into its respective temperature value. This line sends the temperature reading collected into the Blynk app for it to be displayed for the user to see. V4 is used as a virtual pin on the Blynk app, which represents the A0 pin, and with that, the app will be able to collect and display the temperature readings. This sets up the serial monitor in the Arduino software, which is used to read all the output data coming from the MCU. Over here, the Blynk app is set up with this code to be able to communicate with the Node MCU chip. This is setting up pin D5 to use as the output for the fan. This is setting up pin D6 to use as the output for the Christmas lights. And this is setting up A0 to use as the input for the LM35. This is a simple read function from the temperature sensor to read the temperature. The V2 and V3 pins are virtual pins used on the Blynk app for the servo motor, which switches between the direction of rotation for the motor. When V2 is pressed, the motor rotates 90 degrees clockwise, and when V3 is pressed, it rotates 90 degrees anti-clockwise.
We will now look into the PCB designs made during the project. Here is our protoboard design of the project. We will now be going through it. As you can see over here, that is the Node MCU ESP8266 chip, which contains the Arduino program which powers the entire project. Over there is the LM35 temperature sensor. This collects the temperature of the environment and sends the data to the Blynk phone app for the user to see. These 3 header pins are used to connect the servo motor. Over here, we have the 2 and 2 transistors, which are connected to the fan and the Christmas lights, each of which has a 100 ohm resistor to limit the current. These 3 wires are the power wires. They all are connected together as a common power, each which is used to connect the fan, the LED, and then the one of it goes to the main power source. And over here, the black wires, those are the grounds. The grounds are commonly soldered together as well. After some decision making, we decided not to use the protoboard since it didn't meet professional standards. As a result, we kept this behind as a backup just in case something went wrong, and later on we went ahead with making a PCB. Here is our final PCB design. As you can see, compared to the protoboard, this is much cleaner and it definitely meets the professional industry standards. The overview of it is the same thing as before. Right over here, we have the Node MCU, which contains the Arduino code which programs the project. Down over there, we have the LM35 temperature sensor, and over here, we have the 3-header pin which is used for the servo motor, and this 3-header pin is used for the lithium battery. This red wire is used to power up the LED, and the black one is for ground, and those two holes are used for the fan. We had the two and two transistors over here, and the 100 ohm resistors over there. Looking at the behind, soldiering's done very neatly, much cleaner than the port board. There are some minor issues as well, but that's pretty normal in the world of engineering.
Hi, my name is Courtney Critter, and next we're going to talk about the construction of the house. So initially we had to plan out the house and kind of figure out how we were going to make the lights work and fit the PCB in the house design, but make it so that it wasn't visible. We wanted it to be kind of tucked away, kind of like an actual house would be, where the circuitry is inside the walls and in between the conduit. So we had to plan that out, and we decided that there was going to be a conduit under the floor, under the first floor, in between the first and the second floor, and in the back of the house. And then the roof was going to be kind of like an attic, quote unquote, and we were going to put the extra lights up in the attic. We initially did a cardboard kind of construction, just a prototype of what the house was gonna look like. It didn't take very long, it was just kind of thrown together, and then we went and we moved on to the thicker white styrofoam board that we were going to use for our final design of the house. I did all of the measurements and I cut out the house as best as I could, and we started putting it together, and it turns out that the house just didn't look the way that we wanted it to for our final project. It just didn't meet the quality standards, and so what we did is we just kind of used that as our second prototype. So what we did is we made holes in the second floor, and we made holes at the top where the attic was going to be, and we put the lights in, and everything worked great. It looked fantastic, as fantastic as it could, and it worked the way we wanted it to. So we just used that as our second prototype, a firmer, more dense kind of version of our house. So since it didn't meet the professional standards that we wanted it to, what we did is we bought a model house on Amazon, and we put it together in about a day. We just followed the instructions, and we put it together, the house, the way it was supposed to. We kind of freestyled our own furniture and freestyled the lights as well. So we didn't use the lights that the package came with. We used our own lights, and we just put those around the house, and we made it as professional as possible. What we did do to this house that we bought is we added the same conduit concept that we had for our two prototypes at the bottom of the house. So what we did is we took our foam board and we cut about an inch width, and we measured the outside of the house, and what we did is we created that little conduit so we could put our PCB and some of our extra lights underneath the house, so then again we wouldn't have all the wiring and it would look just a little bit neater.
We will now show the mini house being operated with the Blynk app. Here is our final house design. I will now be showing its full functionality with the Blynk phone app. Here is our Blynk phone app. As you can see, it's very simple and straightforward to use. We assigned pin D6 to the LED since that's the pin we used on the Node MCU to connect it. Then we assigned virtual pins V2 and V3 to the servo motor, and we assigned the virtual pin V4 to the temperature sensor, in which it's collecting the temperature from it and displaying it to the user. Now let's run the app and turn on the LEDs. To run the app, you just press the top right corner over here. It is now running. Now to on the LED, we just tap over here. As you can see, it's going on and off perfectly. Now let's run the servo motor. Here is our front door, which is attached on the top of the servo motor. Here in the Blynk phone app, pin V2 will rotate the motor 90 degrees clockwise, while V3 will rotate 90 degrees anti-clockwise. Let's test it out. Let's run the app. So now when I click V2, it goes 90 degrees clockwise. When I press V3, it goes anti-clockwise. Now let's check out the 12-volt fan with the temperature sensor. Over there we have our fan. The way we set it is it's being controlled with two values, the minimum temperature value and the maximum temperature value. So if the temperature right now is below the minimum, the fan won't be moving at all. And if it's in between the min and max, the speed of the fan will adjust to that. If the temperature goes above the maximum though, the speed of the fan will be at its maximum and won't be able to increase furthermore. So right now the temperature is 18 degrees, which is why the fan isn't working, because right now the minimum temperature is 25 while the maximum is 35. Let's see what happens when the temperature goes above the minimum temperature 25 degrees. Now the temperature is above the minimum, and as you can see, the fan is working. Thank you for watching our video. We hope you found our project informative and inspiring.